Good evening, Titans. This is Mr. Simpson, and we're moving on to section 8.2, graphing quadratic functions in the form of a times x squared plus c. The objective is to graph quadratic functions of that form and to solve real-life problems involving quadratic functions in that form as well. So our essential question is, how does the value of c affect the graph? Now, the new vocabulary term for this section is a zero of a function. And the zero of a function is the value of x that makes the function f of x equals 0. So a zero of a function is an x-intercept of the graph of the function. So if we have the coordinate plane here and we have a parabola, then the zeros would be that point and that point, the points where it crosses the x-axis. So first of all, the core concept is graphing f of x equals a times x squared plus c. Now we've already talked about how the value of a affects the graph. And so what we're showing you now is if we have a plus c at the end, then it's going to shift the graph up. Okay, that's a vertical shift up, as you can see by the green graph. Now, if the c is being subtracted or is a negative, as you can see here. So if we had f of x was equal to 2x squared minus 5, well, this minus 5 would make it go down. And so if we wrote it as plus a negative 5, then the c would be less than 0, and that would mean that the graph would be shifted down 5 units. Okay? So, again, the vertex of a graph in the form f of x equals a times x squared plus c is just the value 0, comma, c, because we haven't shifted the graph left or right. So the vertex still has the x-coordinate of 0, but the y-coordinate would be c. So if we're going to graph this, again, we're going to compare it to the graph of y equals x squared, which, remember, y equals x squared just goes right through the origin, 0, 0, okay? So in this case, we're going to plug in 0 for x, so 0 squared is 0, and then 0 minus 2 would be a negative 2. Then 1 squared is 1, and 1 minus 2 would be a negative 1. 2 squared is 4, and then 4 minus 2 is 2. And 3 squared is 9, and 9 minus 2 is 7. So now my ordered pairs are 0, comma, negative 2. We have 1, comma, negative 1. We have 2, comma, 2. And we have 3, comma, 7. So if we graph these, my ordered pairs, I have 0, negative 2. I have 1, negative 1. I have 2, comma, 2. And I have 3, 7. Okay, and then just as we did last night, again the points are symmetric. So here's my line of symmetry. So I have a point over here, a point that matches up right over here, and then the other point that matches up here. So now I have my graph. Okay, again, so we're using the table of values to find the ordered pairs. Again, I like to pick obviously the point that will give me the vertex, and then I pick 2 or 3 points to the right, and then I use the line of symmetry, and I pick then the 2 or 3 points that correspond to those points on the line of symmetry. So again, just a few more examples here. So if we graph g of x here of x squared minus 5, again I plug 0 in for x, I get 0 squared. 0 squared minus 5 is a negative 5. 1 squared is 1, 1 minus 5 is a negative 4. 2 squared is 4, 4 minus 5 is a negative 1. 3 squared is 9, and 9 minus 5 is 4. So again, my ordered pairs are 0, comma, negative 5, 1, comma, negative 4, 2, comma, negative 1, and then 3, comma, 4. Again, I wish my graphs were a little bigger here, but again, 0, negative 5, then I have 1, negative 4, then I have 2, negative 1, and I have 3, comma, 4. And then again, I pick the points that are symmetric to them on the other side, and I make my graph. Again, notice how the minus 5 shifts my graph down 5 units. Okay, shifts it down 5 units. This one would just shift the graph 3 units. So again, I could just go to 0, 3, then I know it's that same shape. So over 1, up 1, over 2, up 4, over 3, up 9, and get my graph the same way. Okay. Again, plus 3 just moves the graph up 3 units. Now we have one where we have the A and the C involved. So again, I plugged 0 in for x. So I didn't have all the table here. So 0 squared is 0. 0 times 2 is 0. And 0 minus 5 is a negative 5. Now I plug 1 in. 1 squared is 1. 1 times 2 is 2. And 2 minus 5 is a negative 3. Now again, notice I'm using the correct order of operations. 2 squared is 4. 2 times 4 is 8. 8 minus 5 is 3. And the last one, 3 squared is 9. 2 times 9 is 18. And 18 minus 5 is 13. Now you'll see that sometimes I just won't be able to fit all these on here. Alright? And so in this problem here, actually I'm going to use this graph here, I guess. So 1, 2, 3, 4, 5, 0, negative 5. Then I have 1, negative 3. And I have 2, 3. And I can't fit the 3, 13 on. So now I just find my points that are symmetrical. And I graph it. Now notice because of that 2 in front of the x squared, it's narrower, but it's also shifted down 5 units. Now, if we do this next one, I plug 0 in. 0 squared is 0. 0 times negative 1/4 is 0. And 0 plus 4 is 4. Plug 1 in. 1 squared is 1. 1 times negative 1/4 is negative 1/4 plus 4 is 3 and 3/4. 2 squared is 4. A negative 1/4 times 4 is a negative 1. A negative 1 plus 4 would be 3. 3 squared is 9. 9 times negative 1/4. So negative 1/4 times 9 is a negative 9/4, which is actually negative 2 1/4. Plus 4 would be 1 3/4. Now, obviously with my graph, it's going to be pretty hard to see all this, but we have 0, 4, so 1, 2, 3, 4. Then I go 1, 3 3/4, 2, 3, and so you can see how it's a pretty wide graph. It does open down, but it's a pretty wide graph. Again, it's wide because the A is less than 1. It's opening down because the A is negative. But do notice that it's shifted up to 0, 4 for my vertex. Alright. Now it says, describe the transformation from the graph of f to the graph of g, then graph f and g in the same coordinate plane. Now, all they're really doing here, if you look at this is our f of x. So this f of x would be 2 units up because of the 0, 2. It would open down, and it would be a little bit wider because of the half. Okay? And now all that's happening here is that it's being shifted down 7. So that would just shift down 1, 2, and all the way down to a negative 5 here. But it would be the same shape, and it would just be down wider like this. Okay? So now, in reality then, this, it says then graph f and g, and we did that. Write the equation that represents g in terms of x. So now g of x would actually equal negative 0.5 x squared minus 5, because it's the vertex is down at 0, negative 5. But everything else stays the same. All they did was shift the graph down 7 units. And here they ask us to, they're giving us a function, represents the approximate height in feet of a falling object t seconds after it is dropped from an initial height of s odd feet. An egg is dropped from the height of 64 feet. After how many seconds does the egg hit the ground? So if I plug 0 in, well, 0 squared is 0 times negative 64 is 0, plus 64 is 64, so this would be 64. I plug 1 in. 1 squared is 1. 1 times negative 64 is a negative 64. Negative 64, oh, I typed that in wrong. Shoot, that should be negative 16. Sorry about that. So 1 squared is 1. 1 times negative 16 is negative 16. Negative 16 plus 64 would be 48. Plug 2 in. 2 squared is 4. 4 times negative 16 is a negative 64. Plus 64 would be 0. So then I have my graph here, and as you can see, hits the ground after 2 seconds. It says, explain why only non-negative values of t are used. Well, t represents time, so we wouldn't use negative numbers for time. And what if the egg was dropped from 100 feet? Well, then we just have negative 16 t squared plus 100 feet. And we did, again, just plug values in for t until we get it to 0. Or we could set it equal to 0 and solve it that way. So, please open your student journals to page 248 and complete problems 1, 3, and 5. And we'll check these tomorrow in class. Have a good evening, Titans.